In lecture 27, we will be looking at the review question related to the simple topic of loops, such as for loop, do while loop, and while loop. If you want to do some task again and again, obviously you are going to use the loop to repeat a few blocks of code. So let's look at the first question. What happens in a while loop if the control condition is false? Obviously, if it's 0 or boolean false, initially obviously it's not going to run. If the condition in while loop is initially false and the loop is skipped altogether, the statements or maybe one statement inside the loop are not executed at all. Same thing happens with the for loop. If you the for loop condition is false, then which is written in between the two semicolons of the for loop body, if it's false, obviously that's not going to run. However, if you are running do while loop, the condition is actually checked at the very end after running through it. So even if the condition is false, the do while loop is going to run at least once. What should be the control variable for a for loop be declared before? When should be declared? When before the loop instead of within the control mechanism? Because if you're declaring a variable inside the for loop body, that is going to be the local variable. However, if you are declaring it before the loop, that is instead of within its control mechanism, then it is going to be used outside of the loop statement block if it's necessary to do so. Even though we usually prefer that the variables used to control the for loop are declared within that. If in some circumstance if they are used to be applicable or used even after the end of the loop, then we should declare them outside the loop body before the for loop. How does the break statement provide better control of loops? So break statement provides better control of the loops by allowing immediate termination of the loop after any statement within its block. So whenever the break happens, the loop immediately ends and the control is transferred outside the loop to the next line. And without a break statement, the loop can terminate only at the beginning or end of the block. So if you, because that will happen only if some condition becomes false, which is a control condition for the loop to continue. What is the minimum number of iterations that a while loop could make? Obviously 0 if the condition is false, and do while will run at least once. So this minimum number of iterations that do while loop could make is 1, because the condition is checked at the very end after going through the code at least once. What is wrong with the following code while n is less than equal to 100? Single line loop, actually we don't need curly brackets because it ends at the very first semicolon. N is less than equal to 100. Let's hope there is some value declared before that. This n is never updated. The sum is going to be updated, but sum is not the control variable, n is the control variable. So this is actually an infinite loop because the value of its control variable n does not change. If a compound statement S E1, E2, E3 are expressions, then what is the difference between the program fragment? If you have written for, this thing runs only once. This is the conditional expression, either true or false. If it's true, this thing runs. If it's not, then this thing doesn't run. And after running through this loop, then this thing runs for each iteration. After running through this loop body, this thing runs for each iteration, and then this condition is checked. We go through the loop body, we do this, then condition is checked, then we go through the loop body, and it keeps on going forever as long as the loop condition is true. And this fragment, even we have declared some variable or some initial condition, or that is here. This thing is a local variable, and this thing is kind of a global variable, if you want to say that, but this thing is outside the scope of this loop. So there is just one difference. But as far as the running is concerned, this condition is given here, this condition is given here, and this thing is being updated. Might be some kind of an increment or decrement operator applied to some control variable. So this thing is running once after we go through the loop body. So this thing is happening at the very end. So these two code fragments or program fragments are essentially the same. There could be a difference if we have there is no difference between the effects of these two program statements, unless there could be a difference. S is a break statement or S is a compound statement. That is a block that contains a break statement or a continuous statement. For example, this for statement will iterate 4 times and then terminate normally. So this thing, if I equals to 0, I less than equals to I less than 4. So in the first iteration, I equal to 0. If I equals to 2, that is false. So it will continue, and it will go to the next iteration. Before going to that, it will increment the value of I would be 1, I less than 4, that is true. So it will go here. Continue means skip rest of the loop block and go to the next iteration. Next iteration would make I value equals to 3, and 3 would be less than 4, that is true. So at 2 it will just I equals to 2, it will continue, and no statements are written right next to it. It will then go to the next iteration. I would be 3 is less than 4, that is true. It will go to this whatever code is here, and then the value of I would be 4 less than 4 is now false. So this loop will run 4 times. However, if we write this I equals to 0 while I is less than 4, and we write this thing becomes an infinite loop, even though pay attention carefully that I is 0, I less than 4, this condition is true. So if I equals to 2, continue means skip rest of the code block and then come here. But I is now 0 is not equal to 2, so this is false. So I plus plus I would become 1 less than 4, that is okay. So 1 equals to 2, continue, this thing doesn't run, and I value of I would now be 2 less than 4, that is okay. And now if I equals to 2 equals to 2, it just continues, and that means it skips this part. So it comes back here, 2 less than 4, that is okay. 2 equals to 2, it continues. It doesn't work, it doesn't do this part because we are using the continuous statement, and continuous statement says that if this condition is true, skip rest of the loop block and go to the next iteration. So 2 is still less than 4, it will just keep on. The value of I would be stuck at 2 indefinitely, and that would make it an infinite loop. In this scenario, this thing was continuing, but due to the structure of the for loop, this statement runs after each iteration, or after each one going through the for loop. It happens after each iteration, and then the condition is checked. So even though if we have written I equals to 2 and then we say continue, even though we would have written other statements, but this thing would run and the value of I would now be 3. So this for loop would iterate 4 times, but this while loop will go on for indefinite time because the value of I would be stuck at 2 due to this continuous statement. It will just it will prevent this I plus plus to happen when the value of I is 2. What is wrong with the following program? Actually, it is constant double pi. If you are declaring constant, you have to initialize that. So a constant pi is not initialized. Every constant must be initialized. That is a declaration, and once you have initialized the constant, you cannot change its value. So that's kind of a read-only object. What is an infinite loop and how can it be useful? So infinite loop is one that continues without control. It can be stopped only by a branching statement within the loop, such as a break or a goto statement. Let's stick with the break statement, or maybe an exit statement, or by aborting the program using Control C or exit 0. I'm going to discuss this goto statement in a moment. It's important you not use this goto statement, even though this is part of your course, but please do not use it. Okay, so break statement, I mean, if you are not so sure when the input is coming from the user is going to end, or whether if you are not so sure when the program will terminate, depending on the user input, you should be using an infinite loop. And the way to make an infinite loop is you can just write while in the round brackets, you just write 1, or you can just use for and simple double colons and do not write anything in the round brackets of for. That is an infinite loop. Or you can use a do while loop, and you can write 1 in the while round brackets. Infinite loops are useful if they are stopped with branching statements. Okay, how can a loop be structured so that it terminates with a statement in the middle of the block? Obviously, you are going to use the break statement or a goto statement. Goto statement actually makes the program control jump to some labeled code. So let me give you an example. But it's only useful, I mean, do not use goto statement because your code would be unmaintainable, or it's really hard to understand the logic of the code if some other programmer is reading your code. So goto statement is considered quite harmful for program maintainability, but it's only useful if you want to because the break statement only breaks the loop, and it will go, the control is transferred outside the loop. But let's say we have 3 nested for loops. So if this condition is true, if I write the break statement is only going to break the running of this loop only. The control is transferred outside the loop. This loop will run just fine, and maybe it's possible that condition is still true and we re-enter this loop. So but if you are using the goto statement, so goto statement requires that whatever, I could just write cout some statement here, or some any code, but that code has to be labeled, and we write a label of this code with a name and with a colon, and then we write some statements such as cout, whatever, if you want to. So this go to say that if this condition is true, go to breakout, and go to means just exit or break out all of these, or just break away from all of these loops and go right next to it. I mean, if we were using a, and breakout is just a name, you could use your own name here for the label for the statement. If you use the break statement, the break statement would only terminate the current loop in which it is in. It will transfer the transfer the control here, and the outside loop will run just fine again. But if you are using goto statement, you are essentially breaking away from this loop, this loop, this loop, and you're jumping right next to it. So this is break statement is kind of a jump statement, such as we have a continue, and we have a break, and we have a goto statement, and switch statement is also known as a jump statement because the program control jumps to some particular branch in the code. But once again, if you have seen this blog XKCD, and it has a very good book written by its author. I mean, it has this comic. It says I could restructure the program flow or use one little goto instead. So screw bad practice, how bad it can be. So go to some subroutine and then compile, and then that person is attacked by the dinosaur. Actually, if you use the goto unnecessarily, it's highly recommended you do not use goto statement. But only scenario is if you want to break out from some nested loops and you don't want to run rest of the loops, so then you can use goto statement. That's pretty much the only scenario I could find. But other than that, if you are using goto statement unnecessarily, your code will be kind of an spaghetti code, which is hard to figure out that what the logic of the code is. So do not use goto statement unless you are using it in a loop. Do not use goto statement in normal structured programming, either in exams or in your professional life. Why should tests for equality with floating point variables be avoided? Obviously, we have some round of errors. I mean, we were expecting 0, we might get 0.00001 or 1.0 e to the power minus 27, something like that. So after going arithmetic operations, exact values may not be what would be expected. So a test such as x equals to y or y equals to x may not work correctly. In this question, I have used the dev C++ IDE as a notepad. Do not run this program. Obviously, it's not going to run because it doesn't have the main function, and the syntax and these words might not make any sense for the C++ compiler. It's lacking the outside structure necessary to run this code, because you need to include the IO stream as well as the using namespace standard and enclose these things in integer main void curly brackets. So I mean, this is just a simple question. Trace the following code's fragment showing the value of each variable each time it changes. So we have declared a variable float x equals to 4.15, and the for loop starts at integer I equals to 0, and then it checks that 0 is less than 3, and then it goes through the loop. So that means that the value of x is doubled and the value of x is multiplied by 2, and the value of x is updated. Then I++ happens, and the value of I is 1 is less than 3, so it again goes to this code part of this for loop, and this statement runs, and the value of x is again doubled. Then it goes to I++, and I is now 2 is less than 3, that is also okay, so x is now doubled again, and then I++ happens, and I value of I is now 3 less than 3 is false. So the program control exits this or is transfers outside the loop body. So that is written here. First x is initialized to 4.15 and I is initialized to 0, then x is doubled 3 times by the 3 iterations of the for loop. So the iterations of for loop, how many times if the program control goes through this for loop, is actually 3, because I starts at 0 and it then goes to 1 and then goes to 2, and when the value of I is 3, the program control is transferred outside the loop body, which is at this point. So 0, 1, 2, that is 3 iterations happened in this for loop. In this question, assuming that E is an expression and X is a statement, I mean, just using the whole thing as a notepad actually, they convert each of the following for loops into an equivalent while loop. So we have written some condition and some statement. Statement also has obviously some semicolon, and this for loop and this statement also has some semicolon. So equivalent while loops are while E I mean this condition is true, run this thing. Or this thing means if you're not writing any condition or logical expression here which evaluates to 0 or 1 or false or true, so this is taken as always true for the for loop. So for the while we can write true, or we can just write 1 here. It means exactly the same thing, and then we write s, and then we write e, because after each iteration of the for loop this thing is going to run after each iteration. So first we need to run this statement, and then we need to run this statement which happens here. So that these are the while equivalents of the for loop, assuming that s contains no break or continuous statements. In this question, convert the following for loop into a while loop. I starts at 1, I is less than equal to n, some value may be entered by the user, and I is squared. So equivalent while loop would be, we need to declare the variable before the while loop because we are going to use that in the logical expression in the while loop, and then we see out this is statement I square for as long as the and then we increment the value of I to I plus plus, and this thing happens after we go through the loop body, and for each iteration. After each iteration this happens, and then the condition is checked. If the condition is still true, it again enters the loop body to execute the statements contained in the loop code block. So here we are doing the same thing with the while loop. Only difference is that this integer is essentially a outside variable. It's visible within the while loop, and it's also visible outside the while loop. But here we have declared the variable integer I equals to 1 for the it's actually the local to the for loop. Therefore it's only visible inside the for loop. Outside the for loop it ceases to exist. In this question we are asked to describe the output of this program. To run this program you have to include IOStream as well as using namespace standard, and you need to remark these lines because I mean these lines, or I could just remark here. The code file would be updated to your class folder, so you can edit them as per your liking. So the output, we need to figure out the output. So it runs a code, and these statements are not enclosed within the curly brackets because there is no need to, because if this condition is true then these else's are not going to run, or if this condition is true then the rest of the, I mean if this condition is false then this will run, or maybe this will, or maybe this. So for the for loop there is essentially only one semicolon at a time. So either it could be this semicolon or this semicolon or this semicolon or this semicolon. So for loop there is essentially only one statement which can possibly run if any one of these conditions are true. So we do not need to enclose these four statements in curly bracket, because at any time only one statement is going to run. So if you want to, yes, you can enclose them into curly bracket, but it's not required to. So it's up to your preference whether you want to do it or not. So let's go inside this for loop, and it says for I equals to 0, I is initialized to 0, I less than 8. So this condition is true. Let's enter the for loop. So I remainder 2, 0 remainder 2 is 0. So it's going to see out the value of I is 0, 0 plus 1 is 1. So first output is going to be 1. Then if this statement is true, if this condition is true, so these else's are not going to run. So we go again here to I plus plus, I value of I is now going to be 1, and 1 remainder 2 is not equal to 0. So 1 remainder 3 is not equal to 0, which is 1, and 1 remainder 5 is not equal to 0. So this is also false. So else it will just see out I with the value of I is 1. Then it will go here again, and value of I would now be 2. 2 is less than it, that is true. 2 remainder 2 is 0, so it will run this line. So I plus 1 would be 3, and that output is here. Then it will go to this point. The value of I would now be 4. 4 remainder then I would be I would be now 3. So 3 remainder 2 is not going to run because this condition is false, and 3 remainder 3 is 0, so it's going to output 3 into 3, that is 9. So this 9 is written here, and then I plus plus would happen. That would be, because I mean if this statement runs, this statement and this statement is not going to run because these conditions are false anyway. And if this runs, so we do not go to this, we do not go to these branches, and the control is transferred to this point. So I is now 4. 4 is less than 8, that is true. 4 remainder 2 is 0, so the value the C out is going to print I plus 1, that would be 5. Then I plus plus would happen, the value of I would now be 5. 5 remainder 2 is not equal to 0, 5 remainder 3 is not equal to 0, but 5 remainder 5 is equal to 0. So this line would run 2 into 5 is 10 minus 1, that would be 9. Then I plus plus would happen, and the value of I is now 6. 6 less than 8 is okay. So this I remainder 2 is 0 because 6 remainder 2 is 0. So I plus 1, 7 would be printed on the screen, and then the value of I would now be 7 after running this increment operator. 7 remainder 2 not equal to 0, this thing is not equal to 0, this thing is not equal to 0, and it will just output 7, and the value of I would be incremented to now 8. 8 less than 8 is false, so the control is transferred outside the loop body at this point. So at this point in this question we are asked to describe this the output of this program. So I equals to 0, initialize to I equals 0, 0 is less than 8, we enter the loop body, 0 remainder 2 is 0, so we see out. Let me write the value of I, so just to remind myself what the value of I is at the moment. This C out would print 0 plus 1 1, and since this if is true, these else's do not run, and it will see out end of the program. So this one and this the end of the program is going to be printed, and then we go to the next iteration. The value of I would now be 1, so let me write that. 1 remainder 2 is not 0, 1 remainder 3 is not 0, 1 remainder 5 is not 0. It will just see out another program, which is this line, and then it will go to I plus plus written here, and the value of I would now be 2. So 2 remainder 2 is 0, so it will going to print 3, and it's going to print C out. So we have 3 and C out, and in the next iteration I plus plus will happen, and the value of I would now be 3. So 3 remainder 2 is not 0, but 3 remainder 3 is 0. So it will continue means escape rest of whatever is written here, because this else is actually run, so this thing is never going to run anyway. So this thing this whole loop iteration is going to be skipped, and it will go to the next iteration, and the value of I would now be 4 after running this I plus plus. 4 remainder 2 is 0, so it's going to print 5, and it's going to print C out, and these else's are not going to run because if logical expression is true. So it's going to print 5 and end of the program. So it's going to print 5 and end of the program. Then the value of I would now be 5. 5 remainder 2 is not 0, 5 remainder 3 is not 0, 5 remainder 5 is 0, so the loop is now broken and the control is transferred at this point. So this is going to print after running this line, and we will see last end of the program here. In this question, we are asked to write and run a program that uses while loop to compute and prints the sum of the given number of squares. So let's say if the user enters 5, the 1 square plus 2 square plus 3 square plus 4 square plus 5 square, the sum is printed. So I mean the next two questions are also same with the different kind of loop, so you can use any loop if you want. So when we are asking the user enter a positive number, you have to include IOStream as well as the using namespace standard, and you need to remark these lines to run this code. Okay, so enter a positive integer, and that integer is stored in n, and the sum is initialized to 0, the counter is initialized to 0. So it compares I with n, which is 0, and then after comparing this, instead of post increment operator, we this I is going to be incremented. If you do not like this, what you can do is you have to run then two statements here. So first statement is going to be this, and the second statement is going to be I plus plus. So if you are not happy with what I've written here, then instead of writing this part, you can enclose that in this part, so you can remove these I plus plus if you want to. So coming back to, I mean these two mean exactly the same thing, but since now it becomes a compounded statement, so we need to use the curly brackets. So coming back to the original structure, so I, which is 0 less than n, that is true, and then after running this line, the value of I is going to be incremented to 1, then 1 into 1 is obviously 1 is going to be added to sum, and then again here we come back to this thing, and this I 1, the value of I is 1 is less than n, and after running this line, the value of I would be 2 because it's a post increment operator. So this 2 into 2 is squared and it's added to sum, and the value of sum is updated, and come back here, the value of I is now 2. 2 is less than 5, whatever the user input is, let's assume it's 5, and after running this line, the value of I is now going to be 3, and the 3 square is going to be appended to sum, and the value of I is now 3. 3 is less than 5 still, and after running this line, the value of I is going to be 4, and 4 square is going to be summed up, and then after running this line, the value of I is now going to be 5, and 5 because initially after running this iteration, just before that, the value of 4 is going to be compared with n, and that is still less than 5, and after running this line the value of I is now going to be 5 because it's a post increment operator. The value is used first and then incremented. So 5 into 5 is squared, so that would be appended or added to sum, and this coming back here, the 5 is going to be compared to n. 5 less than 5 is false, so we go outside this loop, it's no longer true, and this cout is going to be printed. In this, I mean, we exactly the same problem, but we are asked to use the for loop. We initialize the I to 1, I is less than, let's say, 5, and the I1 square is going to be appended to sum, then I plus plus happens, the value of I is now 2, 2 square is going to be, 2 is less than 5 obviously, so 2 square is going to be added up to sum, and the value of sum is updated, and the value of I would now be 3, 3 is less than 5 or equal to 5, then 3 square is going to be added to the sum, then value of I is going to be 4, 4 square is going to be added to the sum, then value of I is 5, then 5 is less than equal to n, that condition is still remains true because we have an equal to sign here, and 5 square is added to the sum, then value of I is going to be upgraded to 6, 6 less than equals to n, which is 5, that is false, so the control is transferred at this point, and we say the sum of the first so many squares is whatever that number is. In this same problem, that enter a positive integer, we are using a do while loop. So here this I is I starts at 1, we cannot start at 0. If you want to, you can use there, but it's anyway not needed. So 1 into 1 is 1 added up to sum, and then I plus plus 1 less than 5, this is true, and after running this line the I plus plus first the logical check happens that 1, which is I, is less than n, and after running that logical check the value of I is going to be updated to 2 because it's a post increment operator. Then we go back here, 2 square is going to be added up to sum, we come back here, and this 2 is less than still equal to less than 5, and after running this logical check, this is true anyway, so 2 is updated to 3, 3 square is added, then 3 is checked with compared with n, which is 5. Then value of 3 I is going to be updated to 4, 4 square is going to be appended to sum, then value of I is going to be 4 is compared with n, and that is still true. So after running this line the value of I is going to be 5, 5 square is going to be added up to the sum, and then here this I 5 less than 5 is no longer true, so the control is transferred at this point. In this question, we are asked to write and run a program that directly implements the quotient operator, which is the division operator, and the remainder operator or the percentage operator for the division of positive integers. We know that multiplication is repeated addition. Let's say if you want to multiply 2 with 8, you can use a for loop to add up 2 8 times, so you get 16. Similarly, the division is actually repeated subtraction, and we know from the previous lecture that subtraction using 2's complement is actually addition. So we are not going to into too much detail there, but let's say I want to divide 8 divided by 2. So 8 divided by 2, I need to subtract 2 from 8 as long as we have a remainder or we have a value which is less than 2. So let's say if I subtract, let's make a count here, let's make a count. I need to divide 8 divided by 2. So if I subtracted once, so let me write that in comments. So if I subtracted 1, so 8 minus 2, that is going to be 6. So that is first subtraction. Then 6 minus 2 is going to be 4. That is the second subtraction. And 4 minus 2 equals to 2, that is the third subtraction, and 2 minus 2 equals to 0. So we have this final value which is equals to 0, which is less than 2. So we have done the subtraction 4 times. That means 8 divided by 2 should yield the quotient of 4, and it should give the remainder equals to for example, it equals to 0. So let's say if we divide 7 divided by 2, 7 divided by 2, let's say we need to use 7 divided by 2. So how many times can we divide, or how many times can we subtract 2 from 7? So 7 minus 2 is 5, that's one subtraction, and then 5 minus 2 is 3, that is second subtraction, and 3 minus 2 is 1, that is the third subtraction. Now we have 1 which is now less than 2, or the denominator, so we need to stop there, and we can say that the integer result of this division as we can say that, or how many times we could have subtracted 2 from 7 is 3, and the remainder is 1. So 7 divided by 2, the quotient operator should yield 1, and so it should yield 3, sorry, and the remainder operator should yield 1. So I have written the code here. You can go through the debug mode to understand what is happening here, but it is simply repeated subtraction that this program directly implements the quotient operator and the remainder operator for the division of positive integers. The algorithm used here apply to the fraction numerator divide by denominator, or n by d, repeatedly subtracts the d from the n until n is less than the denominator, which is like this part. Okay, so, or 3 divided by 2 if you want to. At that point, the value of n will be the remainder, and the number q of the iteration required to reach it will be the quotient. So we are taking the numerator and we are taking the denominator. We are starting with q equals to 0, or remainder, or q equals to 0, which is quotient, and remainder equals to n, and then we are going to update the value of r, because we are subtracting it, and we are going to update the value of r again and again after running this thing, and we are going to check as long as this condition is true, keep on subtracting. If this condition becomes false, do not subtract anymore. So after going through this, the cout of this says that n divided by d is the whatever the quotient is, and how many times if we have divided that. So n percentage d is going to be the remainder after running through so many subtractions. In the last example, I'm not going to explain this code because I'm out of time, or the allocated time of the 30 minutes as requested by some student, because the lectures are quite long. So you can use it. If you do not understand this code, then message me. I will try to explain it in some future lecture. This program, run a program that reverses the digits of the given positive integer. The trick here is to strip off the digits one at a time, take it the digits one at a time from the given integer and accumulate or append them in reverse in another integer. So we have a positive integer, let's say 1 2 3 4 5. We divide, or we take the remainder, that will be the rightmost digit, and then we remove that digit because we are doing the integer subtraction, and then we are appending it by because this thing is going to be appended that digit or to the new number in the reverse order. So n would be 10 into n plus t, and we keep on doing this as long as the value of n is greater than 0. When the value of n reaches 0, because we are continuously dividing it by 10 and it's an integer division, this thing is going to be this loop is going to end, and we say that we reverse. Let's say if we have a number 1 2 3 4 5, the answer should be 5 4 3 2 1.